So we planned this session after the last couple of meetings, and what we would hope to do is just give a little bit more time for people to present some of the work that's going on in fetal CMR and CMR in pregnancy, and perhaps just like encourage a little bit more time and space for interaction from other groups who are interested, really just to help sort of, be visible and to show what people are doing, and also sort of encourage a bit more sort of dissemination and ideas within the group. So you probably all know about the LinkedIn group. I was just saying before others joined, it's a little bit difficult for me to work out the best way of communicating and sort of disseminating to people. It's a little bit slow through SCMR, and I'm kind of working on that. We have the LinkedIn group if you want to join that, and that just, I can post stuff up there, and obviously that's a very quick way of sending links and other bits and pieces. And the formal group is on that second link. And I will try to sort of join things up a little bit. It's just being a little bit slow going with that. Developments. So thank you to Josh and Erik and Tom, because they've put together this GitHub resource. This is what it looks like. That's the address down at the bottom right. I don't know, maybe if one of you guys wants to just say a few words about that and kind of what you'd hope to sort of get from others who see it or contribute to it.
I can do that. Yeah, I mean, this was just sort of out of, from the last meeting where people were saying it'd be nice to have a sort of common repository for mostly technical, I think, resources. So sequences, reconstructions in particular, sequence parameters, or anything else that, that we would want to sort of make the rest of the group aware of. What we've done so far is just set up a bare bones container with a nice site on the front end of it that we can just dump things into. So really it's entirely empty. The space between the notice and the contribute there will be filled up by all kinds of things, so long as we want to do them. We could link to reconstruction software for metric optimized gating, or put a note down there for the Doppler ultrasound device, just somewhere where we can kind of collect these things. So yeah, this is the start, and then we'll just grab the information from everyone and start to make sense of it as we collect it.
Excellent, thank you. And thank you guys for the work you put into that. I think that's like, you turned that around really quickly, to my mind at least. So I think that would hopefully just be a really nice, a nice resource for people to sort of see what's out there and potentially contribute. So if you want to contribute, please, see the page or contact myself or Josh or one of the guys who's involved with that. And then the other thing I was going to mention is something we talked about, and I just if there's anyone on the call who wasn't involved with that, something we were thinking about doing at a very early stage is looking at pulmonary lymphangiectasia prenatally with MRI, particularly in groups like hyperplast with restrictive septum, obstructed TAPVD, and really with I guess the sort of concept is looking at sort of less florid, or at least radiologically florid types of that condition, and how to interpret that. And I think a lot of groups had some experience with those types of cases and had some difficulties with that, which doesn't seem to be something which is hugely covered in the literature. And I had a really nice positive response from the team in CHOP who said they were very interested in being a part of those discussions. So I think the next thing will be to set up a kind of preliminary meeting, just exploring some ideas about how that might work. Obviously, from a point of view of MR, it's relatively straightforward in terms of sequences, and it doesn't require any sort of post-processing or anything. So it's something that could potentially be relatively accessible. And if it's something people be interested in, then let me know. You can contact me directly. Can you see the slides okay, or can you see like the faces on the side? I'm not sure exactly what I'm sharing. Can you see the whole slide?
Yeah, it's the whole slide.
Yeah, great.
Yes, it looks full.
Great. Okay, well, I'll probably stop because I think we said that we'd start with the Toronto group, and I think Josh and Mike were going to say a few words about that. So I'll hand over to you guys, and then we're hoping to sort of do about 15 minutes of talking, and then if anyone wants to ask any questions, or you can certainly do that after the speakers have gone, and we'll have a little bit of time at the end. So if there's sort of more general questions you want to ask to the whole group, then by all means you can do that, and we can sort of do that towards the end and wrap up. Speakers will be Josh and Mike, and then we have the group from Hamburg going to speak. I'll speak myself, and Erik Hedstrom hopefully will contribute from Lund. So 4 different centres, 15 plus 5 each. So we should be done in sort of an hour and a half. Okay, I'll hand over to you, Josh. Thanks.
Great. Yeah, you'll just need to enable screen sharing for participants first.
Okay. Now.
But yeah, so the format here is going to be that Mike will speak a bit about the experience and the sort of more practical details, and then I'll cover some of the more technical. Mike had asked me to do the whole thing here, but it quickly became evident I couldn't probably cover the. Here we go.
Yeah, should be up.
Wouldn't be able to cover the more sort of practical aspects of things. So we decided that he would take that. Screen sharing has failed to start. One moment.
Don't worry, Josh, I can, because I was just going to talk anyway rather than show slides. Okay.
But yeah, so effectively, just as a guiding, let's go back to the beginning here. There we go. So yeah, we've got sort of, those were the questions that we were asked. And we kind of categorized them, and I've color coded them here. So I'll leave it on this slide for Mike, and I will mute my mic for a little bit.
Thanks, Josh. Yeah, so I guess I can describe the history of our experience in Toronto, which was really that it started off as a research project that Chris McGowan and I decided to try together. That was back in about 2008. When we really thought that it might be interesting to try and image the heart with MRI, the fetal heart with MRI. And at the beginning, we didn't have any approach to gating, and we simply used to enter a sort of estimate heart rate into the scanner and try and do some imaging like that. We called it pseudo gating, and I would usually try and do some scanning in patients that had been referred for a fetal brain MRI. So they were mainly second trimester, and I would get 10 minutes at the end of a scan, depending on whether the mother was really willing to carry on, and that was enough, for us to get an idea of what the challenges were, and we started this work on the metric optimized gating, which was a lot of developmental work by Chris, and then some kind of validation work by me with patient volunteers, and doing some kind of simulations in adult volunteers. So we did require ethics for our initial scans, and once we had got the gating system going, we felt that there really wasn't much point in trying to carry on imaging second trimester fetuses, and so that's around the time that we decided to start trying to recruit our own patients for research studies, which essentially we started with normal controls, and scanned them as close to the end of the pregnancy as possible, and attempted to do flow measurements in the fetal vessels using the optimized gating approach, and that then evolved into research project looking at both congenital heart disease patients and IUGR patients, and that was really the first 5 years or so was just trying to do some purely research-based scans looking at fetal circulatory physiology in those patients. Since then, we've started to get a few referrals for clinical cases, and we've continued having research projects more around things like maternal hyperoxygenation now, where the patients are essentially coming purely for a research scan, again in late gestation. But we sort of had a trickle of referrals for clinical reasons which we don't now feel that we require ethics approval for, you know, that has been improved, that has been enhanced dramatically by the ongoing sequence development, particularly of the SINE SSFP, which we now feel provides us with good anatomical imaging and functional imaging of the heart, at least in the 3rd trimester. And so some patients in which there are problems with the echo for whatever reason, if there are poor echo windows or it's really an unusual sort of anatomy that our fetal cardiologist would like another imaging modality, then we will do those on a clinical basis. And we do now have a way of getting the OHIP fee for doing those MRIs. That's our way of getting the remuneration for the scan. They're all reported by me. I don't tend to provide a lot of information about the extra cardiac features unless I see something obvious. I am a pediatric radiologist by training, and so I hope that I would notice anything really important about the extra cardiac findings, but I don't go into a lot of detail about those. So that's sort of our reporting approach. I guess what else have I got to cover here on this list? I mean, challenges about the practical issues. I mean, these are primarily still to do with the amount of post-processing that is required for our technique, where we segment the fetus to measure its weight, and we do a lot of mapping for oximetry and hematocrit calculation, and then we do the post-processing for the flow measurements. And so reporting a case is you know, several hours work, and so I have only really been able to do that by having research fellows or students to help me, and even then it's quite difficult for me to provide anything approaching a clinical service, which of course you have to remember in fetal medicine is really quite different, because the patients generally expect the results of their scan, you know, within a few minutes of it being done. That's what they're used to with ultrasound, and so it's really quite difficult to deliver that when you're doing fetal cardiac MRI, especially if you're sending data off to the cloud for reconstruction. So you know, it's not unheard of that we would actually get the data and a report sometime after the baby's actually been born, in which case it's not terribly useful clinically. But anyway, I guess that's part of the ongoing challenge that one's institution would need to invest in some manpower to actually be able to make this a practical imaging service, I think, and I haven't really achieved that in my own institution. So I think that was really, I mean, I guess the main thing is that you know, where the referrals come from. And so in my hospital, it has been either that I've directly recruited patients myself for research studies, or as I say, a sort of trickle of referrals for clinical questions from my colleagues in fetal cardiology. And so that's a sort of tertiary fetal cardiology program run by cardiologists, but very much from a practical point of view, done in tandem with the maternal fetal medicine program across the street in the hospital across the street. So that's pretty much the state of things in Toronto. And Josh has got some numbers of cases, I think, to show you, and he will also tell you about the protocol and the equipment that we use. So these are fetal MRIs done at SickKids for the last 5 years, and you'll see that we're on about 25 cases a year at the moment for purely for cardiac. And still, you know, vast majority is second trimester brain imaging in our place. And you know, certainly I was doing a lot more back in the early days when it was you know, my main research activity was to do this stuff. So so that's sort of how it's leveled out, is about one case every 2 weeks, I guess. Josh, do you want to talk about the sequences?
Yeah, happy to. David, I should keep this to about 5 minutes or so.
Yeah. I mean, yeah, I'm sure we'll probably catch up with time, so don't worry too much. But yeah, that'd be great.
Oops, there we go. So yeah, I've just got I think about 4 or 5 slides about some of the more technical stuff, equipment, and sort of the protocol, which covers sequences in terms of acquisition and reconstruction. And then I think that's about it. So basically got 2 scanners that we use here, but primarily this is all done on a 1.5 Tesla Siemens with a 60 centimeter bore in our heart center. I think so we've got at least one research study going right now on the Research Institute's 3T, which is also a Siemens scanner. So those are the scanners that are used here. And then just some details on the sequences that are used. But broadly speaking, we've got a 3D SSFP for the fetal body weight estimation that Mike was talking about. And that is the only maternal breath held sequence of these. All of the Cine, 2D Cine SSFP and the phase contrast are now radial case-based acquisitions. And then those use metric optimized gating for the cardiac synchronization, internally maternal free breathing. And I'll share some details about that in a minute. And then there's this sort of magnetization prepared SSFP for doing T2 and T1 weighted imaging, from which you can do T2 and T1 estimates, and then use that to look at blood oximetry. And then there's also a haste sequence for looking at the lung parenchyma that David showed one of those earlier on. There's some additional details here. I don't think I'll go into most of those, but this is all in a table as referenced below. I can share it later on as well. But those in general are the sequences. I suppose I should also note the sort of pseudo-gating that Mike was speaking about before. That's what's used right now for the magnetization prepared SSFP for the blood oximetry. So that's based on a sort of a pre-MRI estimate of the fetal heart rate, if I'm not mistaken. But we are going to actually trial the Doppler ultrasound gating device there, and that it might be particularly useful for synchronizing that acquisition to the fetal heart rate. So just a quick slide about motion correction in the radial acquisition. So that's recently we've changed, dropped all the Cartesian, SSFP, and phase contrast, and using exclusively a motion corrected. And the idea here is that you do a golden angle radial acquisition. That's what's on the top, I don't know if you can see my cursor, but top left of that first diagram. And then you can take the spokes and rebin them in various ways. First doing sort of a low temporal resolution real time to do motion estimates and data rejection. Then in a higher temporal resolution real time to do the metric optimized gating to get things synchronized with the heart. And then you can bin them according to a cine and get a reconstruction. And Data has published a paper on this recently, last year, looking at Cartesian versus radial. And the nice thing about radial is that you're more motion robust and certainly don't require reacquiring sequences quite as often. And then one slide on the blood oximetry. You can see sort of the T1 weighted SSFP top left and the T2 weighted SSFP bottom left. And they give estimates of the T1 and T2. With those combined, you can actually look at the intersection of curves in sort of hematocrit oxygen saturation space. And that's useful for getting an estimate of the hematocrit. You only need that once, and you can apply it elsewhere. So you'll see actually in, this is sort of, I had a full list of the exam sequences. I actually reworked it because I thought this was easier to look at, but these are basically the sequences in order for sort of a standard typical examination. So that includes the localizers for maternal abdomen up front, and then the sort of 3D SSFP looking at the whole fetus. That's the image that you see on the right there. That's followed by 3 orientations of the fetal trunk using the Cine 2D SSFP, the radial acquisition there. And I'll touch on that in a second. And then looking at various vessels. And so the prescription of these can be a bit tricky, but using the Cine SSFP is actually quite useful. Right now, actually on the scanner, it's this time averaged, so it's sort of a static image that is reconstructed there. But that is still useful for figuring out the scan planes for these. And it's only in the umbilical vein and the descending aorta that phase contrast T2 and T1 are acquired. And then subsequent vessels where blood oximetry is of interest, the T2 is acquired along with the phase contrast in the same plane. And then in some of the smaller vessels, it's just the phase contrast. And so, yeah, a quick word on sort of our offline reconstruction, because these radial acquisitions can be computationally intensive. With the radial K-space reconstruction requires some nonlinear or non-uniform fast Fourier transforms, and GPUs are quite useful for that. They're also, as you kind of could tell, quite iterative, and so computational demands go up quite a bit, and the scanner systems can be somewhat limited there. So what we've done is leveraged this is Yara, which is shown at the top, and you've got sort of the MR system sending data off to the recon server, and we have one of these excuse me, set up now in our high performance center. Excuse me, and then it just reconstructs the data using the same MATLAB or Python code or whatever we would be using, and then can add DICOM tags and transfer it back to a network share or PAC server. And this has been, it can be a little bit slow, I suppose, like Mike has suggested, but I would say it's actually improved access to these reconstruction modules, because you no longer need to send the data off to a grad student or some researcher and then wait for it to come back. Now it's somebody at the scanner can initiate a reconstruction and have things sort of move on from there. It's also been useful for very systematic archiving of research data, and allows us to actually add on some supplemental stuff. So for some of the reconstructions with the metric optimized gating, for example, we add on a sort of quality metric image and send that off as well. So I think that was it on our side. I'll leave it at that, and then we have time for questions, I guess, now or later. We'll follow David's lead there.
Thank you so much, Mike and Josh. So I guess, like I said, I think we can have a little bit of time if there's really specific questions you want to ask to the people speaking. If anyone wants to do that, put your hand up or just start talking. Otherwise, we'll carry on and just keep moving through the talks. So any questions?
Yeah, hey, Mike and Josh, I think, great presentation, and it's a great summary. I have just two specific questions. One for Mike. If you can elaborate, your fee structure currently, if you get a research-based versus a clinical fetal CMR, and what reimbursement, is it full reimbursement, or you have to go through some other hoops to basically make sure it's survivable? And was there any support from a vendor when you initially started to develop fetal CMR? Was Siemens able to help you in any way, developing any infrastructure? And one question for Josh is, for the offline image recon that you showed, again, the same thing, was the system already in place, or you needed to get some more infrastructure to make it working?
Okay, shall I start then? First thing was about the fee structure. So in Canada, we get basically a standard rate for an MRI, and our hospital created a billing code which distinguished it from other MRIs, but basically it just gets billed as an MRI to the province like any other MRI. And I only bill the ones that I'm requested clinically. The ones that I do for research, I have to pay for with grant funding, or make an arrangement with the hospital that I can use the equipment without paying. So I did a bit of both of those, doing out of hours scanning for research myself and that kind of thing. The question about the industry support, we certainly had some meetings with them. We still haven't got our sequences into as product, as you know, but we've got a research agreement with Siemens, which has allowed us at least to modify the sequences to make them fetal, suitable for fetal work, and we can share those through a C2P agreement that we have with Siemens. So any other Siemens vendor would be able to, user would be able to use our sequences as long as they have a research agreement with Siemens. So that's about as far as we've got with it so far. I don't know if Chris wants to add anything to that. He's the one who does most of the heavy lifting with this sort of thing.
Well, Siemens does provide contacts for us, at least, too. I think that's something that's been useful when we've run into roadblocks and standard clinical research interactions with their research partners within Siemens. But for the most part, we've had to sort of push it ahead on our own, I would say.
And then there was a question for Josh, I think.
Yeah, I can address that. So it was about funding for the offline reconstruction. We've received an infrastructure grant that's sort of broad and multi-hospital, and part of that was assigned to developing sort of shared imaging research computational resources in our hospital. And so we've leveraged part of that. So there would be certainly costs involved, but I don't know if they're huge for implementing something like this. They're not trivial, but they're not, I wouldn't see them as a major barrier necessarily. But the implementation was then, there's labor involved in that. And so I'm a little bit grayer for it, but I think we benefit from that. So yeah, hopefully that answers the question, but.
Yeah, great, thank you.
I've got a quick question on coil selection. So especially for the 3T, you've used the 18 channel. Is there any particular reason why you haven't gone to any higher channel, or was it just what was available at the time?
That's just what we've got. I don't think we would have anything against going to more coil, to more of a higher number of array.
May I comment on that, please?
Yeah. Hi, Erik.
Hi, Mike. Great. Very, very happy to hear your presentation. I'll refer back to that later. So when we started out, we actually started out with a 30-channel coil. And we had some very strange artifacts that we thought initially were sequence related, but they were actually due to some very basic crosstalk between coils. So we do a combination of the spine and the 30-channel, and we also have all the pregnant women in the lateral position. So the coils were too close together because it's large. So we went to the 18 and all the artifacts actually disappeared immediately. I believe if one is scanning in the supine position, the 30-channel coil could potentially be beneficial.
Yeah, it'd be interesting to hear others' perspective on that. Certainly when we looked in the early days at accelerated imaging, the high channel count might lead to poor overlap at the center of the maternal abdomen. So you might see less, worse image quality centrally in the field of view. So that's one of the reasons I think we favored compressed sensing over parallel imaging. There was another comment I wanted to make about the channel counts. Oh, as you see higher channel counts for neuroimaging, that tends to lead to really high cortical signal to noise while sacrificing the center of the head. So even in other body parts, we see these trade-offs, and I think we might be facing those, like Erik suggested, as we go up in channel count.
Okay, any more questions from anyone before we move on?
Briefly, sorry, with the use of 3T and 1.5, was there a big difference between the two magnets?
Yeah, so it was it was more of a practical choice because our cardiac, most of our cardiac work and kind of ease of access to cardiac, ease of access to the scanner was for the 1.5. I think there's certainly probably some benefits of higher field strength, and we certainly see those with the flow measurements. I'm not so familiar with trying to do cine SSFP at 3 Tesla in the fetus, although it worked quite nicely in animals. The SSFP can be tricky at 3 Tesla, and so for locating vessels, I tend to use a gradient echo sequence just to get the my anatomical landmarks. But I think the Hamburg group have been working with 3T and probably know much more about optimizing cine imaging at that field strength. The oximetry, we haven't really had much success at 3 Tesla in human patients. I don't know why that is. I think that there's quite a lot of artifact, but it worked again very well in sheep. That's how we validated all our oximetry stuff, was to do oximetry in sheep. So I think it is possible. Of course, the T2. The relationship between oxygen and T2 is different. You get much shorter T2 times, and so it can be that it's harder to distinguish between different oxygen saturations if everything's shorter. So those would be my thoughts about the different field strengths.
Okay, thanks, thanks, Mike. Thank you, Josh. I think probably we'll move on. And I'll quickly present the sort of background from our unit in the Evelina. And I can say before we start that so all of our work to date has been on a Philips system on a 1.5T, and that continues to be the case. We haven't explored using 3T, although we have access to them. But I think for a lot of the technical reasons that have been outlined, we haven't gone there yet. I think that would be a lot of work to move on to the 3T, and we're not sure exactly what benefits we would get from that. So certainly with the type of imaging that we do. Okay, so I'll keep it. I think the focus of this is really the focus for us, really, which has been from a very early stage. We were very integrated with the clinical fetal cardiology service here, which is a large kind of, if you like, sort of quaternary referral fetal cardiology center. And that's really been the sort of foundations of all of our experience, and is really how our program guided how the program's develops. If people are in the CMR, the congenital CMR, SCMR talk, there'll be some overlap with that, so apologies, but it's very similar, along similar lines. So this is us, St Thomas's in London. We're opposite the Houses of Parliament, which is why you always see a picture of that rather than the hospital when you look for us. So we're St Thomas's. Evelina London Children's Hospital is within Guy's and St Thomas's, and King's College London is our university partner. So that's just sort of explaining there's lots of different names. Essentially, we're all the same thing. The clinical side is Guy's and St Thomas's, and the Evelina, and then King's College London, KCL, is the university partner. So when we initially started, this was back in 2014. As I said, we had this really sort of from a very early stage integration with our clinical colleagues. And this was based on the reason we were actually getting women in the scanner was because we're very fortunate to have a good relationship with the Center for the Developing Brain here, the Department of Perinatal Imaging, who had a really strong track record and a very established infrastructure for fetal MRI, particularly brain MRI. And we had a relationship with them, and with women on the scanner, we started to explore the idea of doing MRI sequences for the heart. So I think we were very lucky to come into a very mature infrastructure in terms of fetal MRI imaging. That was all pretty much, certainly what we were involved with is in a research domain rather than a clinical domain, but we were able to have a lot of those sort of infrastructure problems solved from a very early stage. So what we did is we said, well, we're getting women on the scanner, we can scan. We're interested that group were interested in brain development and congenital heart disease, and we said to our clinical colleagues, refer to us patients who have a fetal diagnosis of congenital heart disease where you think that there may be added value from additional imaging. So it was a pretty broad referral criteria. And actually, some of the interesting things that we discovered quite early on was what that pattern of referral looked like. And certainly for our colleagues here, we were seeing a lot of referrals that were asking for more information or better quality imaging of the vessels. So the extracardiac vasculature, particularly things like coarctation, which is obviously very difficult to diagnose prenatally, other types of aortic arch anatomy, pulmonary vasculature, so arteries and veins or other vascular things. And that was really the bulk of our referrals. The sequences that we were using at the time were adapted from, to two main types of the Hayes sequences like Josh was describing. So single shot Fastman echo sequences, which give this sort of black blood contrast. So on the left, you've got an aortic arch with respect to coarctation. On the right, some very abnormal looking pulmonary veins. And these were taken as a stack through the fetus. And we would sort of sift through like a needle in a haystack looking for the diagnostic images. Obviously do your best to plan at acquisition, but in a moving fetus, it was often a lot of repeats and a lot of time sifting through the data afterwards. But we did have some success with that, and particularly these sequences were good for the vessels. And we also had some balanced sequences, I'll show you some examples later, which gave us more sort of intracardiac contrast, as sort of bright blood imaging, but were much more artifact prone and probably slightly less useful. So these seem to be the ones that seem to be the most useful in answering the question that we were being asked. The issue was that these were stacks, and as I said, you had to sort of go through them in some detail afterwards. And again, very luckily, we were working in a very strong fetal imaging department with a very strong computer science input, and they were looking at doing motion correction for the fetal brain based on input data, which was multiple stacks, so multiple overlapping stacks of data, albeit motion corrupted because they were acquired in a moving fetus. And essentially using the information in those stacks to iteratively register the slices to a kind of evolving three-dimensional volume of a region of interest, which worked very well for a static organ like the fetal brain. And because this was just a real perennial problem for us to get sort of consistent imaging, we thought we'd try and apply that to the fetal thorax. And actually it worked well. And I think it worked well, particularly because the question that we were being asked was the extracardiac vasculature, which is relatively static in the chest. The chest itself is relatively static. It's fluid filled, minimal sort of deformation, if you like, non-rigid deformation within the chest and the vessels themselves. And we had very little contrast in the heart, so that didn't particularly interfere with the way the algorithm worked, which is all in image space. And we got these really nice results where you got this sort of three-dimensional volumes essentially compiled from multiple overlapping two-dimensional stacks. So again, I think that really worked well for us in the environment that we were in, and was a nice synergy between what we were being asked from a clinical point of view and then what we could ultimately provide. And we did a lot of sort of due diligence on that, and we published a couple of years ago a sort of validation paper, but essentially showing that these were sort of around about representative, and they tallied well in terms of measurements with echo, but also very reliable. Seemed to work. An important point, we were sort of imaging around 30, 32, 34 weeks. So sort of early part of the third trimester. And I think certainly seemed to cope relatively well with the amount of motion you might see in a fetus at that gestation. So, very reliable and really improved visualization of those vessels. And as a result of that, we developed a list of clinical indication based on our experiences. And, like I said, there was certainly some synergy in terms of what we could do with MR and what we were being asked to do. But we developed a list of clinical indications, and they're listed out there, mainly vascular. Hypoplastic left heart with the restrictive septum is mainly for the lung imaging. And then the bottom two are sort of some more novel indications, and this is based on some work we're doing at the moment, which is really expanding on that motion correction to look at generating essentially 3D whole heart sequences from the bright blood imaging. I'll talk about that. In terms of funding, we made a case, certainly after we went through the process of validation, and I think at that stage we probably had a few hundred cases that had been through the scanner. We were, like Mike, certainly if there was a clinical indication, we were always reporting that and feeding that back to the clinicians. And again, we were lucky because there was a team here who were always reporting the fetal brain. And we did have some radiology support from the general radiology team who would give us the rest of the body, if you like, and offer sort of reports on that. So we had a good experience, and I think that experience was backed up by a lot of clinical input and reporting. And we made a case for that to be funded through our National Health Service, and that was accepted. So we can now, for clinical scans, be remunerated for the cost of those. So just some examples, again, I think probably just to show you sort of why these techniques are useful. So this is an example of what's actually a hyperplast with supracardiac TAPVD. Motion corrected reconstruction, obviously a bit of time going into the segmentation and sort of coloring in, but I think you can quite clearly see the anatomy. And this is obviously the type of thing that would be very difficult to elucidate prenatally from 2D echo, certainly. And this was actually a case that I showed you the image of before. This is a case with pulmonary lymphangiectasia in addition to that. So hyperplast, supracardiac TAPVD with signs of obstruction and a lymphangiectasia. So potentially a lot of added value from the MR in this case, complementary to the echo findings and prognosis. Complex vascular anatomy, again, sort of cope relatively well from that. This is 32 weeks on the left on the MRI. This is a pulmonary atresia VSD MAPCAS, complex anatomy, right arch, aberrant left subclavian, major collaterals or sort of ductal collaterals coming to the left and right PAs. And again, that was borne out postnatally. And I think again, this just removes some of the uncertainty in the prenatal diagnosis from two-dimensional echo. And this actually allowed us to really get our surgeons involved at a very early stage, counseling, all those sorts of things, rather than waiting for postnatal imaging. Tetralogy with absent pulmonary valve. So less of a sort of direct anatomical question, but this is one that obviously with the grossly dilated pulmonary arteries, you can see on the posterior sort of aspect image on the left, big LPA and RPA, very typical for this condition, no duct. And on the prenatal MR, we saw this very lobar changes in signal, essentially sort of fluid trapping in the lungs. And that was born out postnatally. This baby had significant airway issues and was dependent on ultimately on long-term ventilation. Was in hospital for about 10 months, I think. So again, just something we could add prognostically, which would be very, very difficult to stratify that risk simply from echo. So it's sort of added value of MR from a clinical point of view. Right aortic arch and vascular rings, this is something we've looked at quite extensively. Something that we're seeing more and more often, certainly in terms of screening in the UK, something that's been picked up more and more often. And this is just an example of, and this is from Milu, I think, who's on the call, an example of mirror image branching, which I'm sure you're all familiar with, and a double arch. And I think what we're seeing a lot in these cases of double arch is that the left arch is smaller, but actually sort of set back along the duct. And when postnatally, when the duct closes, you often completely lose not just the ductal sort of lumen of the duct, but also that distal arch. And you can have an impression very much on postnatal imaging that this may be more like mirror image branching, and there'll be some very subtle features to help discriminate from that. But I think when you have the prenatal imaging, which is convincing, this is actually something that you can say is additive in terms of risk stratification and everything else from prenatal imaging, which you couldn't really image these things postnatally. You'd have to infer them. Coarctation is a big sort of pipeline of work for us, and very much in the research domain. And I think that's because classically this is just a condition that's extremely difficult to predict. You know, coarctation essentially is something that develops when the duct closes. So when the duct is open, it can be very difficult to predict the postnatal course. And I think actually we found that essentially MRI isn't necessarily a sort of silver bullet with that. We can get good imaging of the arch, and we can look at the anatomy, and we can make the sort of same kind of subjective judgments that you might be able to make. But we are looking into whether there are other things that we could be measuring in a little bit more detail, which could help us refine that. And that's still helpful to have this type of imaging, but still a work in progress until we can sort of work out exactly how to make it really robust. So our current setup is that really mainly through the clinical pipeline, we are scanning about 2 to 4 cases a week. The vast majority of those do consent to have, consent for research, which means we can, if we need to run extra sequences, we can obviously use their sequences for research purposes after we've acquired them. We have myself and Kabiran Pushparaja, who's also on the call as the lead for the service. And when we've got 2 fellows, Johannes and Milu, who are fantastic and are very involved with overseeing the scans, processing the data, and drafting up the reports. As I said, we were very lucky to have an established MRI infrastructure, and that includes midwifery support. We've got very experienced fetal radiographers who can do a lot of the sort of basic fetal scanning. We often need to step in for some of the more complex things as we go, and administrative staff. And as I said, the brain and body are still reported routinely in all of our patients. So this is just, so again, this is thanks to Milu. This is our referrals over the 12-month period. The first 12 months we were running as a clinical service. And this is just to give you an idea of the, obviously the sort of spread of cases that we were seeing on the right. Of the 127 referrals that we had, 25 weren't scanned. I think 8 of those were for COVID reasons, 8 of them for reasons that were probably inevitable, things like termination or they delivered prematurely, and 8 who simply didn't want to be scanned or DNA'd and were very difficult to sort of pin down. So actually the number in terms of, sort of, if you think about patient acceptability, I think the numbers were relatively low of people who sort of refused to scan or ended up not coming for one, and the vast majority were able to scan. Once we got them on the scanner, our completion rate was good, and even in those ones who didn't have a complete protocol, which mainly consists of the Hayes sequences, we were able to report and answer the clinical question in almost all of them. A few just bits about sort of future work streams. So this is actually some work when Josh was here. And essentially this is again looking at that sort of post hoc image processing, but this is these are what the balance sequences look like. This is the type of contrast you get from those. And this essentially uses a combination essentially of inferring a heart rate from the sort of changes in frequency within the data, binning out into the different phases of the cardiac cycle, and then essentially applying a very similar reconstruction algorithm. I probably massively oversimplified that, and I know Josh is on the call, but that has been published and potentially very useful. It gives us sort of 3D whole heart type imaging with time, and this is where we're starting to explore things like looking at relationship between the VSD and the ventricular chambers, things like double outlet right ventricle. This is a case of aortic atresia with the VSD, and this is just a sort of a rendering of the blood pool, but showing that this is from an RV aspect, again, just the relationship between the aorta and the PA. And when you have questions of complex rootability, I think this is something that potentially could be quite useful, as well as adding things from, may be useful from a research point of view, ventricular volumetrics, for example, and those sorts of things. We've used it in tumors, for example. This was a large tumor abutting the right ventricular walls. We did some tissue characterization in that, but also could just show exactly how the tumor was interfering with the heart throughout the cardiac cycle. And I'll just finish up. So this is Tom Roberts, who's also on the call, and an extension of Josh's work essentially, but using the same balance sequences and inferring essentially from the overlapping data and the changes in every voxel from inflow in blood, but obviously in multiple sort of orientations that you have, you can kind of solve essentially the direction and velocity of blood flow at each point. And this is just some early work, essentially looking at getting 4D flow, which may be something we could, may help with the acquisition side of things. So we're not planning, we have used some of the metric optimized gating that the guys in Toronto have used, but this could potentially simplify some of the planning for that and give us flow rates in a sort of consistent volume. And 4D flow, I mean, sky's the limit in terms of what you can think of for the applications of that in the fetus, but this is sort of potentially some exciting pipelines, all in the sort of same sort of data, and that just extensions of very similar sort of ideas. So that's been our approach, mainly clinically focused, and really sort of trying to build, if you like, a very comprehensive MR study which parallels what we would do postnatally. And I think particularly the vascular imaging is the bit that really supports the service. And I think there's a good relationship now between that method and the clinical team, and what they expect we can do and what type of referrals that they send, and lots sort of potentially that we're developing in the pipeline. That's the group, and that's the sort of 4 of us at the top, but it's obviously a very big group from the clinical side and from King's. Okay, I'll stop there. Okay, again, so yeah, any questions? I'm very happy to take them if anyone has anything specific they'd like to ask.
Yeah, hey David, just one quick question. How much scan time would you expect for clinical indication? And do you tailor your scanning protocol for the indication, or you have something standard that you do on every patient that comes for fetal cardiac MRI? And what do you do for gating?
Yeah, so all good questions. So we do have a standard protocol. If we're thinking about the clinical indication, or what sort of sequences we use for clinical scanning, we tend to use HASTE sequences orientated to the whole uterus, the brain, and the thorax, usually 3 orthogonal planes. And that gives us enough overlapping data of whatever we're interested in. So if we're interested in the thorax, we'll probably have at least 9 to 12 overlapping stacks of the thorax. So if, for example, the brain, 3-plane brain imaging will include 2 of those planes will include the thorax. So it doesn't really matter how those are orientated. Doesn't have to be sort of canonically acquired. Anything that's overlapping data we can use. That whole haste pipe, that whole haste sort of chunk of the scan is probably about 20 to 30 minutes in total, maybe a little bit less with our newer sequences. So it's not a huge amount of time on the scanner. Post-processing, just to put that in there as well for that particular thing. So we essentially use some GPU accelerated computers to do that. The algorithm that we use is published and is widely available. I'm sure we can actually link that through on the GitHub site as well. That's on those types of PCs, which we're talking, I mean, not cheap, probably like Josh was saying, not sort of cheap, but not kind of astronomical. You're talking about perhaps 5 to 10 minutes for a reconstruction time, so that's actually pretty good, and maybe 5 to 10 minutes of manual time around that. Segmentation takes a bit longer. So that's pretty much it. I guess if you had a purely anatomical question and you wanted to answer it, that's probably how we take. In reality, on the scanner, because we're often doing other things as well, we are up to an hour on the scanner, running some of the KT's balance sequences, for example, or other bits and pieces like flows. But so we try and limit it to an hour, mainly for patient comfort. But the actual sequence time for the reconstructions isn't actually that bad.
Great, thank you.
Okay, any more questions before we move on? I'll take that as a no. Okay, so I think, did we say the group from Hamburg were going to speak next, I think, which was Manuela, Janine, and Fabian.
Yeah, thanks, David.
Okay, thanks, guys.
Can you see the screen?
No.
It's not good.
But we could before, like 10 seconds ago.
Not so experienced in screen sharing, eh? Let's do it this way. Share. Do you see it now?
Yeah.
Yeah.
Yep.
Okay, perfect. And this should not change it.
Perfect.
Okay. So our experience in fetal SCMR, so it's me, Manuela, and Janine who will talk about this. First, one thing I need to mention, I'm also a co-founder and director of North Medical, actually a startup that is a spin-off from the University Medical Center in Hamburg. But I think it's always good to mention that I have two roles. First part will be the technical setup. So I will talk a little bit about the ultrasound gating stuff. Then the second part will be with Manuela about the organizational setup we are doing in Hamburg. And the third part is Janine, who will talk about the cardiac protocols and MR scans and show a little bit how we are doing it in Hamburg. So basically, as Mike said, we started with the same question in 2012, actually. How do we do fetal cardiac MRI? We have a lot of movement artifacts. The heart is beating very fast, so we can't image it. And then there was the idea to, how to get rid of the artifacts. You get a synchronization signal. So we thought about, okay, how can we get this cardiac gating? How can we implement this? And then in 2012, it was a funny idea by just using ultrasound. And then we used, you can see it here, very old cardio topogram actually, that was, I think, found somewhere in the cellar or something. And then we said, okay, can we use that? And then we started out with imaging sheep, actually. So we started with animals. And this was very early work done with Manuela. And this is the setup. So it was a very experimental setup that I think, failed often, but sometimes it also worked. And then we took it one step further. We said, okay, if this is not really working, let's do it properly. So we built a first prototype to actually detect the fetal heart rate. So you see here the early prototype on the left side, and the right side, it's screen when it detects the fetal heart during MRI. And then you have your gating signal and your heart signal, and then you can actually use it how you know your cardiac imaging protocols. And this one is actually, you can use it for 1.5 and 3 Tesla, but you would need to change the cable because it's only compatible depending on the cable you use, because in this cables are cable traps to get rid of the interference between the MRI and this device. And then next step was actually product development. So we thought, hey, when we have a prototype, let's try to make a product out of it. And so we that was the reason when we actually founded the company also. And that's the thing you see on the left side. It's you can use it for 1.5 and 3T. So the cable works for both. And as it's like a normal technician, not only is not really used to find the fetal heart rate. We thought acoustic feedback would be nice. So we actually thought about headphones, and you can see it on the right side in the Philips MRI system. That the cable is also quite long, so it's 1.20 meters long or something, so that the device is not inside the bore. So inside the bore is only the cable. And then here you see how the setup is. And then I'm sorry, that's my little son. He wants to speak with me. You see on the video the actually trigger signal, which is sent to the MR, and the Doppler signal. And the nice thing here is the Doppler signal is the real heart movement. So if the fetus is actually moving, you also see this in the Doppler signal. So you know when to scan and when not to scan, because you know the fetus is actually really moving and something is going on. You also see hiccups or something. So, you know, that's why my image quality is bad, because the fetus has a hiccup. And this also happens. And yeah, that's from me. And Manuela will now talk about a little bit about the infrastructure.
So I will talk about the perspective of the pregnant women. They are mostly referred for abnormalities of the central nervous system for fetal MRI, but increasingly they are sent for cardiac defects as well, and they are scanned by a maternal fetal medicine specialist. We do the whole body, fetal echo, and the central nervous system. Fabian, are you still there? Because I would need the next slide. Fabi? I heard his son talking,
yeah,
so maybe
we may have lost him to his son.
Yeah, maybe I will call him because I can't move there.
Oh, something moved. There you go. I think you might be back on there.
No. Yeah. So we start by scanning the women, and back in 2020, last year, we moved from 1.5 to 3 Tesla. We were forced, as we don't have any 1.5 anymore in our hospital, and we moved to the new building of the Kinder UKE. Fabi, next one, please. And there's a pediatric radiologist. We start with the scanning of the central nervous system. These are now the main referrals for fetal cardiac MRI. We have 1 hour slot for our patients. So we do half an hour central nervous system, and then we have another half an hour for fetal cardiac MRI. Mostly patients agree to do research, and sometimes, Fabi, can you do the next one, please? They are sent only for cardiac defects, but I think this is starting like half a year ago or something, mainly because we talk about it, and now the obstetricians in Hamburg know that they can send some women with congenital heart defects, but it's not very common now. So we have volunteers, we have central nervous system abnormalities, and very rarely we have congenital heart defects, but the numbers are increasing. And now we have 3 slots a week. So every Wednesday we have 3 times 1 hour to scan the women. And we started with 1 hour a week, and now we are improving our numbers, and we hope that in the future we will have a lot more pregnant women to scan. So Janine, now I think you are talking about the setup.
Can you hear me? Yeah? Okay, perfect. I'm going to tell you a bit about the examination setting, about our protocol, and basically about the practical way that we do the examination. So here you can see what it looks like every Wednesday in Hamburg. So we place the patient either in supine or left lateral position, whichever is most comfortable for them. And then we place the transducer of our fetal cardiac gating device that you can see on the left on the maternal abdomen just above the fetal heart. And that's how we get the CTG signal that we use for cardiac gating. And we don't put the body coil directly on the patient, but we use kind of space keeper that you can see on the right. And on the bottom, you can see the white feet that we've just recently, perfect, thanks, Fabi, that we've just recently printed in a 3D printer because actually the space keeper was too low for the abdomen of our pregnant patients. So now it fits perfectly. And what it actually helps us is it increases comfort for the pregnant patient throughout the examination. And it keeps the body coil from pressing on the transducer and from moving it, because sometimes we'd lose the signal because of that, and we don't have that problem now. Can you go on, Fabi? This is the CMR protocol that we do now. We are working at a 3 Tesla Philips MRI. And basically the first 3 sequences we use for planning, and the Cine BTFE short axis view and the 4-chamber view. These are the actual Cine sequences that we do for the assessment of the fetal cardiac anatomy. And what we've also been working on is 4D flow MRI. Basically, I think the difference between the methods that most of you are using and our method is the direct cardiac gating. So we can perform the MRI similar to how you would do it in adult CMR. You could basically do any CMR sequence with the cardiac gating that we are doing. So I think in the past, we also did 2D phase contrast MRI, but you could also do T1 mapping, T2 mapping. Okay, can you go on? So because I think what we are doing is a bit different to what you are doing, because we don't need any post-processing, I'm just going to show you the practical way that we do the examination. So it's similar to adult MRI. We do the survey, and then we do coronal and axial T2 weight images. Next, Fabi. Then we take the axial T2 image and we do a pseudo 2-chamber and a pseudo 4-chamber view. It's exactly the same as an adult CMR. Next. Then we get the short axis, and next. With the short axis and the pseudo 2-chamber view, we get the actual 4-chamber view. So I think the big advantage is that we get the Cine images directly at the scanner, so we can look at them, evaluate the image quality, and if it's not good because fetus moved, for example, then we can just repeat it. Can you go on? As I said, we've also been working on 4D flow MRI, and the planning is actually quite easy. We take the T2 weight images and we plan the raw data on it. And then we do the post-processing, which is, it doesn't take that much time actually. We've tried a software recently, and you can not only do these videos as you saw, but we can also do quantitative assessment. So the lines you see down there, for example, they show the blood flow velocity over a certain period of time in each of the planes that we put into the fetal aorta. And yeah, basically we were able to visualize also smaller structures like the ductus arteriosus and the foramen ovale. Yeah. Is there another one, Fabi? Or is this the last one?
That's the last one, I think.
Okay. Okay, then I'm at the end.
Thanks.
Okay, excellent. Thank you so much to the three of you. I guess again, I'll just throw it out. Any immediate questions from anyone dialed in? No?
Can I ask, how do you deal with fetal movement?
Manuela,
we wait.
Yeah, not so much. So we're not. We can't account for that really.
So we do the scanning at the late second, early third trimester. So we try not to do the scanning with like 20 weeks, even though we have the triggering. We try it, so it is feasible. But baby's moving so much that I think it is a late second, early third trimester indication. So we have done a lot of scanning with 34, 35 weeks, and then the baby moves a little bit less. So amniotic fluid is a problem as well. If you have a lot of it, baby is moving around. So we wait, then we have to reposition the probe, and then we have to get into the room and start all over again. Yeah, so movements are a problem, hiccups as well. But we see the movements and then we just wait.
Okay. And can I ask how long do you have your women in the scanner? Do you have like an idea of how often you need to do that, or sort of a time limit on your sort of acquisition?
So at all, we sometimes they are 1 hour in the scanner because we start with the brain and then we go on to the heart. And lately we didn't have to reposition it anymore, but I think last year we had to have to do it like once or twice. Janine, what do you think? So lately when you started into our group, we don't need to reposition it a lot, isn't it?
No, we don't need to reposition it a lot. I think the gating signal is actually quite stable.
Yeah.
And yeah, the women in there are in the scanner tops 1 hour, I'd say. Yeah, usually it's half an hour brain scanning and then it's half an hour cardiac scanning.
So it's getting better now. So on Wednesday, we had a woman for central nervous system abnormalities. The probe was there and we didn't have the signal. And when we stopped with the central nervous system, we wanted to start with the heart. It was there after half an hour, so we didn't get in again. So, and the signal was stable for another half an hour. So I think Fabi improved a lot the signal, and now we don't have to reposition it a lot.
Okay.
But before we had to do it like twice or three times.
Yeah, that was
even though the fetus was moving a lot. So on Wednesday, it was a fetus that had a lot of movement, and still we had a good gating signal after half an hour. So that's definitely improved. Yeah.
And so I guess that was a little bit part of my question is, do you think that's improved because there's actually been technical enhancements to the device itself, or is that something that's come with experience about how you site the device or something else?
No, that's technical advancements of the gating device. Yeah.
Probably because we're using the new version now. It's a little bit more sensitive. And another thing is that I think actually positioning is really important. So it could be that you get a nice signal, but if you are on the edge of the acoustic window, it just needs to move about like 1 centimeter, and then the signal is gone. So, but if you position it correctly, like straight over the heart, then the fetus can move a bit, like a couple of centimeters, and you still have the signal. So it doesn't matter. So positioning of the probe is really important.
Have you got
but even though the technique improved, because in the beginning I had to position it, because I do that every day, and now Janine is a radiologist and she can position it within seconds, and then the signal is good.
Are there any particular tips for positioning the transducer?
Usually we ask the women if they had a CTG before and where the CTG was done. So I'll start there actually. And if you don't find it, you do the survey, the localizer, and then you see the heart, and then you can reposition it if needs be. But usually you find it. You know, you just ask the woman about the position of the fetus, and then you know where the heart is. It's doable, yeah. Even for a radiologist like me.
Do you try and put it over the baby's back, or?
No, even the baby, normally the back is like here or there, and then you put it there. If the back is here, you try to put it a little bit, not over the back, a little bit beside the back.
Okay, over the baby's side.
Yes.
Okay. Do you find much variation in fetal lie that affects your reading as well? Have you found that, or just not?
You mean the position of the baby, or?
Yeah.
No.
Okay.
So I think it is in the beginning when you start doing it, maybe you have to learn that you have 4 positions where you can put it on the belly. So, and whenever you know that there are 4 positions, depending on the baby's position, then I think it will not affect anymore how you perform.
And do you scan left lateral, the mothers, or supine?
Either left lateral, supine.
Okay.
Now we are doing more often supine, actually.
And have you tried using this for pediatric or adult patients with arrhythmia, SmartSync?
We're actually just trying that. We're in the middle of it. We got some funding for the adult MRI, and we've got like first tries, first results, and it looks like it could be an advantage for patients with arrhythmia. Yeah, so we compared that to ECG, and sometimes it really is an advantage. And we are also planning it on a pediatric collective.
Is the gating device approved for clinical use, or if any centers have purchased it or adopted, do you have to go through regulations or anything, or it's clinically available?
In the past, you had to apply for IRB approval. So everyone who has been using it so far has IRB approval. And now, actually today, the certificate for Europe should have been here, but it's actually delayed. I think next week we'll have the certificate for clinical use as CE certificate. And then you can just use it without ethics for your clinical scans.
Thank you.
What about those sort of regulatory approvals on the other side of the Atlantic, Fabian?
I think we have been there with Natasha on the old prototype version, right?
Well, that's something called Health Canada approval, which it's not an approval of the device. It's just an approval for its specific use in a research study?
Yeah, that's so for the clinical use. I think so. FDA will come next in next year.
Okay.
I don't know if you're allowed to use it for for clinical referrals based. So if it's a research scan, that's the only thing we can do right now. I know that Erik is doing it in Lund, so maybe he has some input how to do it.
Okay. That's a great segue, Fabian. So I think, yeah, okay, maybe we'll move on. Josh, you had your hand up. I don't know if you wanted to add anything to that. I believe it's gone down.
I'll bring it up later if it's still relevant.
Yeah, okay. So just in terms of time, I think we'll try and finish by the original time I said, which was 6 p.m. here, so another half an hour. But I guess we'll move straight on with that to Erik and Lund as our last speaker. And hopefully we can sort of wrap up and bring up any more questions after that. But if I introduce Erik now, if you're there, Erik, and you're ready to share your screen.
Yes, I seem to be on a very bad connection, so I'm running around, just run up a couple of stairs, excuse the breath. You cannot see my screen, right?
We can see you.
Yeah, okay, that's not good enough today. What about now?
Yeah, got it.
So let me just hide those. And you see the complete presentation. There are no black bars or anything hiding.
No, looks good.
Okay, great. So Ronak and Muniz, thank you very much for the list of points. I actually took this quite literally, and I don't think I have one single image in this, so it's pretty much text only for a basis of a discussion of how we did things, what we learned, to also help those who haven't started yet. So the background for Lund is that we are one of 2 centers in Sweden for pediatric thoracic surgery, and therefore also a tertiary center for fetal assessments. And we have 300 referrals per year for ultrasound related to suspected cardiovascular malformation. Those ultrasounds are performed by pediatric cardiologists, and we have a long-standing research collaboration, but also, of course, clinical collaboration with the pediatric cardiologists, making it quite simple to start out doing fetal CMR in the way that they are driven and refer patients. So we also have, of those 3 to 4 pediatric cardiologists we have with a special fetal interest, we have Katrin Fricke and Misha Batz, and Misha was previously in Philadelphia, pretty much doing all the fetal ultrasounds. One key here is also the cardiac MR group, which was initiated in 1999 by Håkan Arheden. And in the cardiac MR group, we have Marjolaine Peak, who is online, an engineer, PhD student in the group, and also Daniel Salehi, who's a physician and PhD student in the group. And we have dedicated techs. So we let the techs decide on their own who of the techs should be those running the fetal scans clinically. And they came up with 2 persons, and we're very happy about those. So currently scans are being performed by Daniel and the 2 techs. I'm trying to stay away from the scanner as much as possible. Also, at the time, we had a regional ethical board. It's now a national ethical board in Sweden. And since we had almost 20 years, very good track record of delivering on what we promised ethically, it was quite simple to add fetal scans to an ongoing preeclampsia study. So we moved from a postnatal preeclampsia study to a prenatal, and also then including the placenta and the babies. Then a very short word about something we have in Sweden, which is clinical physiology, which is pretty much functional testing of everything except for the brain. So I'm trained in clinical physiology and pediatric radiology. and on a 50% clinical position in pediatric radiology. We are expecting, and I think we have plateaued at approximately 10% of those 300 referrals for ultrasound coming to a clinical fetal CMR. So approximately 30 fetal clinical cases per year, and then on top of that, research cases, of course. We don't have a dedicated time slot. We've always had an attempt to make time available as needed for instance, acute ischemia patients, even before opening the coronary ones. And we also aim to have the women visit Lund, because they may be from anywhere in Sweden, visit Lund for their clinician, their appointment for the ultrasound same day and the MR. And I think that works out quite well, actually. So the timeline, 2014, we started setting up fetal CMR, and why invent everything from the beginning? So we started listening around and repeatedly heard Mike Seed and Chris McGowan's names. So 2015, Antonella Letras in the cardiac MR group and myself visited Toronto. And from that time point, we pretty much started working with a MOG, Cineform and Flow, and then also started developing an in-house iGrasp self-gating cine method. So it's all post-processing methods. 2016, I had the opportunity to be an observer in Toronto and learn from Mike. And 2016, Mike also visited Lund and presented for the group how they do fetal CMR. And we also sat by the scanner and received sequences from Mike. So again, Toronto, Mike, Chris, anyone else from Toronto currently, thank you very much for letting us hit the ground running. So 2017, we were kind of fed up with the MOG and the in-house iGrasp because of the post-processing, and wanted to move to something more direct in gating. We actually tried signal enhancing the fetal ECG over the maternal ECG and the MR scanner and failed completely. So we contacted Fabian Kording and the team in Hamburg, and again, very thankful for having the Doppler ultrasound device prototype since then, pretty much. So 2017 in the autumn, we actually also got an acceptance for opening for clinical referrals for fetal CMR. In 2019, we were in Lund, the reference site for fetal CMR in Sweden. So the indications for clinical fetal CMR, as an overview, it's a second or third line examination even, multiple ultrasound potentially before the fetal CMR. All our referrals are from the pediatric cardiologists who also perform the fetal echo. And I wanted to show a pie chart as David did before and we saw last time from Kings 2. We don't really have such a pie chart. We have a lot of hyperplasts, but that's also because we have an ongoing research on hyperplasts. But the main aim for the pediatric cardiologist is really to know more about intracardiac anatomy and cardiac function. And we get vessels more from cine imaging of the vessels or for static BSFP images. A particular group is those with the restrictive or intact atrial septum pulmonary lymphangiectasia. So I'm very happy to hear about the attempt on going for a multi-center study for that. We think that that may be more of a gray zone than previously described, and I know Mike, David, and others also agree with that. So. And the question was raised about fees, and we've actually been paid for the clinical cases since 2017, reimbursed for that. And we pay ourselves with an internal budget for research cases. We are running on a 1.5 Tesla Siemens IRA, and as I mentioned, scans performed by Daniel and the two techs to make this clinically feasible. We use a spine plus an 18-channel coil. We do pretty much everything non-breath hold with a few exceptions. And our standard clinical protocol is an overlapping set of static BSFPs, so overlapping slices for anatomical detail in a transversal stack for the thorax and then coronal sagittal for the baby. And then we do non-overlapping abdominal transversal stack to save time. We also do a 3D balance FP for fetal volume to normalize flow measurements. And then we do the haste, TRA, and coronal slices for nutmeg pattern, particularly if requested. I'm very curious here about how you do that, because we started out doing transversal only and found some cases where we were a bit uncertain, luckily online on the scanner, so we could add another direction, and we started using the coronal. We are not using the sagittal today because we felt that that doesn't add more value, but I'm very interested and keen on learning how you do, and if it's actually valuable to have a third direction here. And then we do Doppler ultrasound gated Cine BSFPs as a transversal stack covering from the neck vessels to including the heart. And then depending on the requests from the referring physician, we do 4-chamber, 3-chamber, 2-chamber, short axis stack. And we do all these with an interactive real-time sequence for planning. But they're really standard BSFP sequences as used in adults and neonates pediatric scans, just a bit higher resolution. And then we do also the dose-gated 2D flow in vessels of interest. As a backup, we still use the iGrasp self-gating Cine if we, for instance, have a lack of DUS signal and lose that completely. We today do a kind of automatic self-gating post-processing to get the images out. If we have the DUS signal, it's much more work for modeling, particularly to do a manual post-processing reconstruction. So we try to avoid this to the extent possible. And then on top of this, we do research in all our clinical referrals, be it development or validation of sequences. And that's actually one of the key concepts in the cardiac group too, that we really want to have data with validated sequences before we do clinical scans. I was a bit amused of the relation with the radiology colleagues and the reporting. To me, that's a question coming from a cardiologist by my experience. So what we did initially was that we had the two pediatric cardiologists, Misha and Katrin, and we sat down together to develop the report, what kind of structure they wanted to make it really clinically feasible. And we also realized we actually meant different things with some particular words. So we have tried to iron out the differences and to write a report, not just from the radiologist's point of view, feeding that to the clinician, but really being helpful to the clinicians. One weakness is that we have one reporting pediatric cardiologist, so that's me. So I report on the whole body except the brain, because the setup in Lund is that pediatric radiologists report on the fetus, but the pediatric neuroradiologists report on the fetal brain. We try to do joint report with the pediatric cardiologist, also having echo images available to actually enhance the scan more than just having one separate echo and one separate MR, since I'm not performing echoes any longer. If there is any suspected brain findings, we are involving the pediatric neuroradiologists also. So with that, that's the group, and thank you very much.
Excellent. Thank you so much, Erik. That was really, really informative. Any just immediate questions for Erik? Take that as a no.
Coming towards the end.
I think we're coming towards the end. I mean, I think I was actually just thinking as I was watching that, just to sort of say a few summary words. I mean, I think it's really interesting, and it's so exciting. I think, having seen people speak a few times and then looking again today, the different approaches that people have taken, I think, I think that just really shows you that this is a real sort of brave new world and a very exciting time to be involved with this type of imaging. And I think, if there's anything you can learn, I suppose, for those who don't do fetal CMR, that there isn't a set way of doing this. So there isn't one way that's going to fit everyone. And actually, it certainly takes the people to drive it. And I think you've heard from some of those people today. but it's going to also be so dependent on your local needs, what infrastructure you have, the clinical sort of interactions that you have, what people want. And I don't think there's anything set in stone here at all. And that could be from a clinical side, from a research side. I think, the incredible stuff like that Mike's showing, the opportunity to get this type of non-invasive imaging in human fetuses in disease, I think is just an incredible opportunity. So I think there's very many things to be excited about. There's a lot of things, technical solutions that we still need to iron out, and things like imaging at earlier gestation, for example. Combining perhaps some of the problems with gating and movement, which I think was sort of different technical solutions in different places, and there's lots of different ways of approaching that. But yeah, I think overall a very exciting time to be involved with it all. I hope that the talks were helpful. I hope this has recorded, so I will keep it for posterity and find a way of sharing it. And yeah, any final comments? I think Kibiran, you have your hand up. Kibiran, did you mean to have your hand up?
Probably didn't have much. Maybe it was censoring, David. Just say I really enjoyed that, hearing everyone's quite different narratives. The only thing I would say to anyone who is listening, who is starting off, is my only advice is work out what resource you have first, and that resource would be hands on deck and how much time you can commit to this. And then work out how you're going to pay for it. But in terms of engaging your service, I would say you need to go to your to the people who are going to refer to you rather than expect them to come to you. And when we set up our service, it really wasn't a service. And so what we did is what I call a concierge service. You go to them and you say, hey guys, we can do this. And then you do the scan, and then you go back to them and you keep them. And these are the referrers, the fetal cardiologists. You sit with them, you go to their offices, don't expect them to come to you. And if you keep doing that, they start to get used to having really useful information. They understand the data, they understand the limitations of the data, and they know what you can accurately define and what you can't define. And that effectively helps shape what the sorts of pathology we were looking at that David showed in his earlier slides. And so our needs are clearly different because of what we could deliver. And that's different to what Erik has described, and it's different to what Mike has described. And so, as David says, it's to your local need. But the one thing that I think this group can do, and the GitHub has been fantastic, actually, so well done again to everyone who's done that, is help you who are working in smaller teams with less resource to be able to jump through some of those technical barriers. And there are a lot of people on this call who'd be happy to support your efforts in trying to get things going on the ground, getting off the ground, wherever you may be. That's the only thing I wanted to say, is that go to them. My only message is go to them, don't expect them to come to you.
Okay, excellent. Just the opposite of book them and they will come. It's like, no, you need to come and then they will book you. Something like that. Anyway, any final comments?
Yeah. Sorry, Malinka, go ahead.
It's really a logistical question, looking at some of the pictures that people have shown. Generally, feet first or head first, what do people prefer?
Feet first.
Feet first. Okay, anything else before we wrap up?
Yeah, I just wanted to thank everyone really for taking time out and sharing your experience. Erik especially taking time out from the clinic, and all of us finding time to attend this important meeting. It may be repetitive for some of us, but I think it's excellent for the scientists that are just starting. We will learn a lot, and probably we won't mind hearing some of this again in the future after some time, just so that everyone can share what they have learned from this. I just had a couple of questions, general to the group. How many of you are actually taking consent before doing the fetal CMR? And are there any pathways to train research fellows or clinical fellows that are already defined with the clinical goals and timelines?
So, I mean, I can answer the research side of things. We always consent our patients, and we have a very standard format for doing that, which based on the previous experience imaging here, and it's mainly about just making sure that they are well informed and they agree for us to use their data, for example, and disseminate that. So it's relatively straightforward. I think that would certainly be something we could share. Those templates, I think, are pretty out there. So I don't think that would be a problem to share our format. I don't know if anyone else has any further comments on that.
We have, we consent the research volunteers or patients, but we also in Lund have ethical approval to do research in clinical patients. So all clinical patients are asked to, in writing, consent to their future use of data in research. If they're not doing that, they will still have their clinical scan, but we cannot use that data for research.
Yeah.
And are there any special marketing strategies involved once you have a set program to basically make it more visible in the community or in the city? Are there any special things that you have done?
I agree with Kabiran.
Yeah, in fact, I have the opposite. The thing that you shouldn't do is to go out and advertise that your fetal MRI scan is going to solve all patients' problems, because then what you have is you get antibodies that come up in your fetal cardiologist who've been using ultrasound for the last 30 years, thinking you're better than just because you can do an MRI, and then they have a problem as well, because mothers will refer themselves to fetal maternal unit saying, we saw Dr. Hedstrom on the news and he he wants we want him to do an MRI scan, and you can get into a pickle. Always bring them along with you, is my only advice.
Yeah, and I think on that point, I mean, I think in terms of promotion, I think it's very much, certainly from our point of view, it's about visibility within the department in which you work and making sure that you're open and showing things. And I think we were from quite an early stage trying to introduce what we could add with humility. So you're saying what we could and what we couldn't see with MR, but really trying to invest the whole group in the program. So it was very visible what we were doing, and we were trying to incorporate that from a very early stage. So I think that helps. And then I think if everyone's invested and everyone feels they've got a part of it and they can see it, I think that that potentially helps just gain that little bit of traction that you need.
And we only started to issue, I mean, the whole, the first tranche of our data when David was doing his PhD and sorting out this 3D reconstruction that he then published, all of that was on research. It's only after the publication of the validation work that we did that we then feel confident enough to issue start a clinical service specifically in that area.
I think the word you used, David, invested or investment, I think that's key here too. So for instance, Misha and Katrine, the fetal pediatric cardiologists, they are PhD students currently. Peter Luba is their main supervisor, and I am invested, and the cardiac MR group is invested because I'm their co-supervisor. And we have Petru being co-supervisor in the cardiac MR group. So it's really investments going both ways. And if we don't deliver, we tend to remind each other about that.
Okay, I think I'll wrap up there. So yeah, no, thank you everyone who spoke. I think one day this group might be like writing like a position statement on fetal CMR indications, and we'll remember these these early chats, I think, and but that's obviously a way off. So the next one we were planning to do another one of these sessions. Actually, what we penciled in was what's on my exam card and a sort of technical side of things, which I think some of that's been covered. But I think we could probably still do a more extensive technical kind of talk for the next session, and really really drill down on some of the sequences, parameters, some of the post-processing stuff that's being used, and sort of spread that out into a session. And I'll probably just arrange something in sort of 2 or 3 months from now, give everyone a bit of time to think that through. And like I said, contact me if you're interested in contributing to the pulmonary lymphangiectasia study. And yeah, I will be in touch.
Sorry, can I just ask one question before you everyone goes? It was basically on the next session, David, because I think I'd originally said I would be happy to talk about our exam card. And you're right, it struck me as people were talking that the exam cards people use are quite different, which is, it's not a bad thing. I was thinking of talking about sort of how we set up our T2 imaging, basically, and what the thinking behind each of the parameters was and why we choose it and some of the pitfalls. And it was going to be a sort of talk on for the people who are just setting up their service. I mean, I was choosing that one because T2 is our workhorse sequence, I guess. You're not going to start off doing 4D flow or anything like that. That'd be crazy. But it struck me that maybe people in other institutions want to talk about as well their sort of workhorse sequences. There's a lot of 3D BSFP going around, for instance, and other things. So I'd be happy to sort of, I don't know, do 20 minutes plus on why we do T2, some of the sort of sequence parameters, and then can talk about the processing. But I don't, I mean, it's a good sequence that can get you lots of information, but as you've said, David, it's not, you shouldn't definitely use this one. So maybe other institutions want to jump in with what they use as their workhorses as well.
Yeah, well, what I think I'll do is I'll probably take that kind of offline a bit, so we'll do a little bit of planning. And I think perhaps, I guess one idea is that we could have this led by sort of engineering and medical physics, MR physics, physicist side of things. And, like I said, really drill down on the technicalities of it, and be that the sequences like you've described. And I think perhaps if it's led in that way, then it will be mutually, useful to everyone, because you can sort of ask questions of other places and other places ask questions of you, that perhaps, are a bit more detailed than we would have answered in that session today.
Yeah.
So I think perhaps we go with that. And, again, any of the speakers, if there's anyone that you think would be a good person to contribute to that from your unit, or anyone really who's interested in contributing to that, the sort of agenda for that session and some questions, then again, by all means, contact me. Otherwise, I'll just sort of randomly pick a few people. But yeah. Okay.
Cool.
All right. Thank you so much for everyone for joining, and I will see if I can get this video posted up somewhere. Not YouTube, or maybe YouTube. I don't know. I'll figure it out somewhere, and I'll let you know when it's there. If there's anyone else you think you'd be interested in catching up.
Thank you.
Okay. Thanks everyone.
Thank you very much for
Thanks so much, everyone.
participating. Thank you.
Bye.
Bye.